All right, good day, everyone. What we're going to be talking about today is the next step of our factoring process. We're going to be talking about the rational root theorem. One of the things to kind of just note with the rational root theorem is that this particular method is going to be heavily used like without a calculator. So what we've been talking about over the last couple of days of how like typically this lesson's built to have no calculator to actually work through it. This is where it really comes in handy. The process we're going to go through today is basically if I didn't have the ability to factor it, if I didn't have the ability to work out those equations, if I had to basically go into this without technology, how would I be able to solve out a problem that not necessarily is fully factorable? Okay. That's kind of the thing that we're going to look at and how we're going to work through. To do this, though, we need to basically know a couple different theorems. So the first theorem is called the rational root theorem. And the idea basically suggests that if I take the equation P over Q, which basically is just the factors of your coefficients. So if you notice for Q right here, they take the factors of your first term or your leading coefficient. Okay, notice how 1 times 2 would give you 2. Those are really the only two values that can go into a 2. And then P is all the factors of your actual coefficient at the end, okay? Which is going to be for 8, 1, 2, 4, and 8. Okay, 1 times 8, 2 times 4. What you do with those values is you're going to divide them out. So everything listed right here is P divided by Q. So I have to take all positive and negative values and divide it out. So notice how in like the first one, they took P, which was positive and negative 1, Q, which was negative 1, and got 1 divided by 1. Well, they're going to do this for every single value. So then they take 2 divided by 1, 4 divided by 1, 8 divided by 1. Okay, so notice how they have literally all the factors of P on top being divided by that one factor of Q. Okay, because we have to try to get all possible values listed. Okay, now what this creates is basically a list of numbers that are possible zeros for us. All right, all this is really doing is limiting what we actually have to test. Because if you think about it, when you actually try to think of like a possible zero, that could be any value on the x-axis, right? It could be anything from negative infinity to positive infinity. So what we want to do, the rational root theorem, what it really creates is an opportunity for us to kind of narrow down what our possible answers are. In that list circled in blue like there are possible zeros built into it. Now, we still got to follow our rules, all right? We still know that this right here is going to be a degree 3 function. So this is still a degree 3 function, so you know there's going to be 3 possible zeros. So out of that grouping right there, we could have at most 3 of them that are zeros, or we could have some multiplicity ones where one of them could be a zero twice. So it all kind of just depends. But that's kind of the main idea of the rational root theorem, is that instead of trying to say like test every single number on the x-axis, we have a specific set of numbers that we can actually use. Now, the actual testing part's kind of interesting. There's 2 different ways you can actually test. The first one being the factor theorem. Now, the factor theorem is pretty straightforward, okay? If you take all your possible zeros and if you plug them in, the one that comes out to give you an answer of 0 must be a root, or in other words, a 0, okay? Notice how in this first one here, in the example, they're plugging in a value of 1. They work it out and they get an answer of negative 27. So you can assume that 1 cannot be 0 because you got the point 1 comma negative 27. Versus in the bottom one here, notice how they actually plug in a negative 2 and they get an answer of 0. Okay, because I got this answer, then we can automatically assume, according to this line, that negative 2 is 0. And so one of my factors is x plus 2. Okay, so that's the idea of the factor theorem. And that's where it kind of plays into the rational root theorem. If I get all my possible zeros, well, then using the factor theorem, I can test those and see, okay, which one is 0, which one will fit. Okay? The last method is synthetic division, all right? Or in other words, the remainder theorem. The idea is that if I use synthetic division to simplify this and solve, okay, if I actually use this, the idea is that if this value is a root, well, then this value, your remainder, should be 0. Okay? Now, this is a method that is also used. A lot of people like it just because you don't necessarily have to keep using synthetic division. Sometimes you can simplify it and get to an equation that is factorable. But the goal eventually is to use synthetic division to get to a zero. And then from there, if you notice, I actually have a root of the function. Okay. The reason a lot of people enjoy this method of synthetic division instead of just testing all of your answers is because once you simplify it out, whatever is left over becomes your leftover equation. And sometimes that is factorable. So you don't even have to keep doing synthetic division. Sometimes you only have to do it like once or twice and then continue on from there. So let's kind of go through one of these and just talk about like how would I solve it and how would I actually work through it. Now, just for room purposes, I'm just going to cross out letter B here and just work out letter A. Let's start off with this. We have x to the fourth minus 9x squared plus 4 plus 12. Okay? Well, we first want to find our factors of P and Q. Q is always your leading coefficient. So I'm going to start with Q. Make a better Q there. We're going to start with Q. Okay? Q in this case is just your leading coefficient, which is just 1. Well, if you think of the factors of 1, it's just positive, negative, 1. Okay? Next, we're going to find the factors of P. At this point, you'd have 12. Okay, 12 right here is all of your factors of P. So you got to think, okay, well, plus or minus 1, because 1 will go into 12. The next one would be 2, because 2 times 6. And then the next one would be 3. And now we just have to add the factors that multiply with it. It would be 3 times 4, 2 times 6, and then 1 times 12. Okay? So what we have here is Q, which is all of our factors of our leading coefficient, P, which is all of the factors of our ending coefficient. Okay? At this point, we want to figure out all of our possible rational roots. Well, to do this, all I would really have to do is take all of my P values and divide them by the Q. Okay? Well, let's go ahead and do this. 1 divided by 1 would be positive negative 1. 2 divided by 1 would just come out to be 2. So we have plus or minus 2. 3 divided by 1, and we continue this process, would be positive negative 3. 4 divided by 1 comes out to be 4. And for this particular one, we really aren't going to have any difference from our p-values just because we're dividing by a 1 each time. Okay, it's not going to change any of those values. If this was like a 1 and comma 2, well, then that 2 would change a lot because then I'd have to actually split in half those values. Okay? But currently, this is where we're sitting at. We have all these different possible roots. And in this particular problem, they want us to use the factor theorem to find those roots. Well, to be honest with you, to actually find the factor theorem, really this is just guess and check, in which you're going to go down the line until you find your 4 factors. Okay, this basically means I'm going to test all of these numbers. Okay, so for example, I would sit here and I would take my original equation and I would plug a 1 into it. This would be 1 to the power of 4 minus 9 times 1 squared plus 4 times 1, excuse me, 4 times 1, which would stay as 4, plus 12. Okay? Well, if you work this out, this would come out to be 1 minus 9, which is 8, plus 4, or excuse me, negative 8, plus 4, which is negative 4, plus 12, which comes out to be positive 8. Okay? So, positive 1 cannot be a factor. So then we would go to the next one. So the next one we're going to test is negative 1. Well, if I plug negative 1 in, we would get negative 1 to the power of 4 minus 9 times negative 1 squared plus 4 times negative 1 plus 12. If I simplify that, that would just be 1 minus 9 minus 4 plus 12, which actually does come out to be 0. So you know one of your zeros has to be, so if I'm going to list out my zeros, one of your zeros has to be negative 1. Okay? And what you would do is you could just continue this process over and over and over again until you get these values. Now, for this particular one, just for the essence of time, we'll kind of speed forward. Your other zeros come out to be -3 and +2. And this is where it gets a little bit tricky because if you think about it, this is a degree 4 function. You should have multiple values. Well, in this case, unfortunately, because you probably have a multiplicity of 2 at one of those values, you only get 3 particular answers. Okay, that's where like the factor theorem kind of runs into issues because you're going to test all 12 of these and only getting 3 answers. Okay, because you're going to basically test them until you get to your 4th value. But if none of them other ones work, then one of them has to have a multiplicity. Okay. Let's go ahead and just talk about the other version. If I wanted to use synthetic division to solve it out, we'll go ahead and do, let's go letter D for this one. Let's go letter D. So what we would do is we would test these values out until we actually get a possible root. So for example, in this one, we find our P's and our Q's. So P's is our last term, Q's is our first term. We would have the value of 8. All of our possible roots would be, let's see, we have 1, positive -1. We'd have positive -2, positive -4, and positive -8. Q would be the same exact thing. It'd be positive -1, positive -2, positive -4, and positive -8. Remember, I'm just doing the factors of my leading coefficient and my ending coefficient. So now if I work that out, my P's over my Q's, this would come out to be, I would want to take my P value, in this case it's positive -1 to start, and divide it by all of those numbers. So we'd have positive -1 over 1. We'd have positive -1 over positive -2. We'd have positive -1 over positive -4. And we'd have positive -1 over positive -8. Okay? And so notice how I took this one value and divided it by all of these values here. Okay? Now I'm going to move on to the 2, because now I got to take the 2 and divide it by all those values. Well, in this case, we'd have 2 over 1, which would just be 2. Positive -2. Okay, because 2 over 1 is really not going to make a big difference. Ooh, let me rewrite that. Positive -2. Then we'd have 2 over 2. But if you think about it, 2 over 2 comes out to be 1. And I actually have 1 right here. I don't need to rewrite this. Technically, this would just be positive -1, right? So what's the point of rewriting 2 over 2 if I already have it right there? Okay. Next one, we would have 2 over 4, which is 1/2. I don't need that as well because it's already listed right there. And then 2 over 8, which is 1/4, same thing. I wouldn't need that because it's listed right there. Okay, so you could rewrite everything, but then you'd have multiples of the same value. Okay, because for example, if I were to do plus or minus 2 divided by plus or minus 2, well then this would cancel out because it's the same as this. Okay? But that would be the process of finding your P over Q's. I think the only other ones that actually pop up are 4 and 8. So if you go through the whole process, the only other 2 that would actually come up would be positive -4, positive -8. And then from there, we would work this out with using synthetic division. Now let's talk about how you're going to do synthetic division. How synthetic division works is basically I have to use my values to solve this out. So for example, I'm going to use my leading coefficients of all those values sitting up there. Well, technically, this is 8 to the 4th plus 0x cubed minus 34x squared plus 0x plus 8. Okay, because I have to assume that if I don't have a value for my missing exponentials there, then I need to actually fill them in. So now I'm going to set up my synthetic division, and just because I know one of the zeros, I'll just throw one of them in just so I can show you what a 0 value looks like. Let's throw 2 into this. The next thing what I'm going to do is fill out with my leading coefficients. This would be 8, 0, -34, 0, and 8. And how synthetic division works is we always carry the first number, and then it just becomes multiplication, then addition. So it would be 2 times 8, which would be 16. I would add those values to get positive 16. 2 times 16 would be 32. Add those values to get negative 2. 2 times negative 2 would be negative 4. Add those values, we would get negative 4. 2 times negative 4 would be negative 8, and I'd get a 0 at the end. So notice how I get a remainder of 0. That tells me that 2 has to be a 0 of the function. So now what I'd have is I'd count down, and this would be x minus 2 as a 0. And then I can rewrite the equation 8x cubed plus 16x squared minus 2x minus 4. Okay? And then I would just repeat that process again, or I would try to see if I can use grouping method to factor that third one out. Okay? Besides that, we'll be going over this in class today. We'll kind of find methods that you enjoy, things like that. But at the same time, we'll also kind of just talk about how, with using the calculator, how we can make our lives a little bit easier by doing this. Okay? Besides that, have a great day, and I will talk to you in class tomorrow.